sure the live stream starts.
Do they know about floor? It's okay if I mention it?
Yeah, you can mention it. They weren't a President's Challenge team, but that's okay.
No, but just about the university in general.
We can do it after. You just make sure
to go live.
Okay. Just have them tell me. I just want to get a thumbs up when we're live. Are we all good? Live? Do I leave my mask on?
I don't have to thank you.
Good afternoon, everybody, and welcome to the 2021 President's Challenge. My name is Erin Draper, and I'm the Managing Director for Clarkson Ignite. We're so excited today to have our in-person event, so thanks all for coming, and thank you all who are joining us on the live stream event today. This year's topic, again, was Think, Make, Ignite, and the teams persevered through a lot of adversity. Again, this year we had 21 teams and 96 participants. So congratulations to all of you who made it this far and made your way through the President's Challenge. At this time, it's my pleasure to introduce the President of Clarkson University, President Tony Collins.
Thank you, Erin. So I guess I had to show up because it is the President's Challenge, but more than that, thanks. It's really hard with masks, and COVID and everything, but that was a little joke. But it really underscores probably my own personal passion, and that is when you combine inventive and creative minds with a challenge, and particularly a financial reward, then that really stimulates a lot of interest and action, and I think we see it in the President's Challenge. And that's really what's behind all of this. We need to make a better world in many ways, from social to the products and services that we use every day. And so getting our student body into the mindset of doing that every day, carefully, thoughtfully, almost so that it becomes automatic, that you approach anything in life with an open mind, you collect information, and then you create a solution to solve a problem. That's what life should be about. And so I'm just very pleased and proud that we have the President's Challenge, that it gives our student body the opportunity to do that. And today we're going to see the creativity, the innovation come forward, and our row of esteemed judges here. Actually, they're going to be challenged more than probably the student body because creating the solutions, because they're going to have to make choices, which is also something about life, right? We have to choose, set priorities, and they've got the unenviable task of choosing the real winners. So with that, thank you for your creativity, thank you for your innovation, thank you, Erin, for you and your group for all you do to create this day. Thank you for the effort of the teams throughout the entire semester. With that, let the show begin. Thank you.
Okay, thank you, Tony. At this time, we will begin the President's Challenge pitch-off. This year, the challenge consisted of 3 categories: human health, energy, agriculture, and the environment, and products and services. 7 judges representing Clarkson faculty and staff have already worked diligently to review and select the best in category winners for each of those 3 categories, and you'll see those teams presenting today. All of the teams were judged on their ability to clearly identify an opportunity, a target user group, create an innovative solution, and on their ability to develop a working prototype or an example of their innovation. The top teams from each of these categories were notified of their selection as a top team approximately a week ago, and they'll now present their projects. For placing first in their category, each of these teams will receive $2,500, and the overall winner today, selected by our judges, will receive an additional $1,000 prize and have their names added to our President's Challenge trophy. I'd like to thank our esteemed panel of judges for today's pitch-off. Dr. Leonard Johns, the founding dean of the Lewis School of Health Sciences, Dr. Augustine Lotto, dean of the Ray School of Business, and welcome to Dr. Daryl Scriven, dean of the School of Arts and Sciences. Our judges will deliberate immediately after the pitches, and we'll announce their decisions as soon as those results are in, approximately 3 o'clock this afternoon. So at this point, I'd like to turn it over to Matt Hawthorne, our Ignite Graduate Fellow, who will be announcing the teams. Matt?
Awesome, thank you, Erin. So, teams, when it is your turn, please approach the stage. Your time will start when you begin speaking, and you will be provided a verbal warning when there is 1 minute remaining. Each team will have 5 minutes to present and 5 minutes of Q&A from the judges only. There will not be any audience Q&A for this competition. First to the stage, we'd like to welcome Team Quattro, the first place winner in human health. Come on up.
Okay, hello all. My name is Eric, and I'm proud to introduce my teammates Gabriella, Drew, Minot, and Parker, who will be joining us on Zoom. If he can hear me, he can say hello.
Hi.
Okay, so now I'd like to start off with a question to begin. So, who here has ever traveled by airplane before? You can just raise your hand. So I look around and see that many of you have, which makes sense because pre-COVID, airports saw roughly 1.6 billion travelers annually. However, with the emergence of COVID-19, the travel industry and airports in specific have been greatly hurt. Studies released by the Airports Council International show that global air traffic has decreased by a staggering 53.1% since March of 2020. Now, even with the decrease in travelers, airports continue to have a heavy influx of germs, which are constantly being spread by touching luggages and in-person-to-in-person contact. In fact, did you know that 10% of all airport surfaces contain viruses that are harmful to humans? Now, airport current methods used to reduce this germ spread are sanitizing wipes, spray cleaners, and different types of hand sanitizers. However, these methods create serious waste and are not beneficial for the environment long term. Therefore, we as a team have created a UVC light attachment to reduce the spread of germs and bacteria found in airports utilizing ultraviolet light. In a study conducted by ourselves, Team Quattro, nearly 73% of people are comfortable with having their luggage sanitized by ultraviolet light. My teammate Gabby will now talk more in depth about our product and UV light.
Awesome. Thank you so much, Eric. So to reiterate a little bit of what Eric said, we have created a UVC light attachment that will be retrofitted onto any airport X-ray scanner. With the use of UVC light, any pathogens and other bacteria you might find on luggage will be sterilized with a 99.9% effectiveness rating. So, UVC, also known as ultraviolet C, has been used for decades to sterilize and rid surfaces of unruly pathogens. The UVC, the C in UVC, refers to the light's wavelength. Now, there are 3 different categories of ultraviolet light. First is UVA, which is the longest wavelength. The second is UVB, and the third is UVC, which is the shortest wavelength. Our product utilizes UVC because of its short wavelength, and it's so harmful to unsuspecting bacteria, including the flu, the common cold, and also SARS-1, which COVID-19 is a strain of SARS-1. So, because it's so harmful, to those unsuspecting bacteria, it sterilizes them. Also, UVC of the three is the safest for human use. However, there are adverse effects to ultraviolet light, as it can be harmful to the skin and eyes. That's why our product features lead rubber flaps on one side of the product to contain the ultraviolet rays as objects pass to and from the scanner. So, to speak a little bit more about ultraviolet light, the short wavelengths are so small and are able to penetrate the outer protein layer of a given virus, that inclusive of SARS-1. The short wavelengths, once they penetrate the outer protein, they inactivate and or neutralize a given virus, neutralize the nucleic acids in a given virus, ruling it harmless. As you can see, this is a very useful product that should be implemented into airports, as there is an influx of germ spread seen in airports. And just to speak a little bit more about the key features of our product does feature lead rubber flaps on one side to contain the ultraviolet rays that come out. And on the interior, there are 6 UVs lining the interior to ensure a maximum sterilization of objects that may pass through the scanner. Also, one of our biggest uniquenesses that keep us apart from the leading competitors is our use of an attachment. A lot of the leading competitors we found make use of a separate UV machine. Now, machine is not cost efficient, as our product is. It utilizes less material, and it's not space efficient because it takes up large amounts of space, as our product does not. It would be on an already existing airport X-ray scanner. Also, our product also utilizes UVC to sterilize not only airport X-ray trays, but luggage and all forms of baggage as well. That is our product, a UVC light attachment. Thank you. I was afraid that was going to happen.
So, hi, if I can have a first question? Yeah. So, looking at how long does it take to disinfect, how much exposure time does it need to take on the surface to disinfect something?
That's a great question. So UVC, like the certain wavelength, we found research, I believe it's around 286 nanometers is the wavelength. There's been research done that can disinfect less than 30 seconds, but also dependent on how many UV lights, we're hopeful to get under like 15 seconds.
Okay. So it comes down to dose, right? It comes down to the dose of the energy that gets put into the killing? Yeah. So another question is, it looks as though there are UVs on the side, UVs on the top. How do you get the bottom?
The key touch points of like trays and luggage, especially the trays, are mainly on the sides. And we do like recognize that unfortunately you won't be able to get underneath, but the sides are the main points of where you touch. And also your luggage, like the handles and the zippers, will all be exposed to that, which is where the majority of the germs are.
Also, just to speak to this a little bit more, we do understand that it may not be able to sterilize all surfaces, but the point is to reduce as much germ spread as possible. So with that in mind, we did keep that in mind, but it's either, it's reducing more sides than no sides,
Right.
which was great.
So one last question, and then I'll hand it to these guys. If you look at your competitors, right, you said that this is different than them, right, because you can add this in rather than a whole new unit. Are their units sterilizing 360?
So one of our competitors, it's a big, long disinfectant just for the trays, and it seems like it does do the bottom. However, I'm not sure if it,
No, it only sterilizes.
but the thing is what really sets it apart is its attachment. They take up so much square footage, and square footage is money for airports. So we save that extra space for them, so they can like bring more revenue.
Thank you.
Yeah, not to mention it does only sterilize trays, while ours sterilizes the trays and baggage and luggage that goes through.
Thank you.
Oh, so you mentioned airports, and people like us who travel benefit from it, but who really are your broadest set of customers for this product?
What was that? I'm sorry.
Your customers for this product. Who
Who
will
are-
buy your product?
Who are our customers? So actually, Our biggest are their actual airports. So to actually see this implementation in an airport, we would have to speak to their board of overseers, and there are some FDA regulations. It is an extensive process, but the actual buyers would be the airports themselves. And it's custom fit to each airport.
Okay, now, so you're presuming that currently the airports don't have adequate cleaning, sterilizing material?
No. We're under the assumption that they have their methods of cleaning, but we have yet to see through our own extensive research any use of UV sterilization. They do have cleansing wipes, but we are trying to reduce the excess amount of waste that is produced annually, as ours is just a separate attachment that does not create as much waste.
Okay, and how much do the units cost? What do you expect to be your revenue streams from this innovation?
No, you're fine.
So we're estimating that the cost would be like around $400. However, if it's manufactured on a grand scale, then that could obviously go down. And the selling price, we were thinking between $1,000 to $2,500, where our competitors range from anywhere from $10,000 to over $100,000. So not only is ours cheaper, but it's also smaller and it's more effective. So, I mean, if we were to implement this, we would fine-tune our price. But, yeah.
There's about 1 minute left.
Okay, I just have one question. First, let me just say, great product. Everybody can use it, so everybody can relate to it. I just have one question, it's a practical question. So I'm looking at this, and I'm thinking about the times that I'm rushing for my flight. Mm-hmm. So there'll be times when I'm looking like, where's my luggage? It's not coming through this thing fast enough. So I'm staring at the edge of this conveyor belt. And I'm wondering, when that lead flap goes up, is UV light going to shoot out and burn my hand?
No, that is a great question, and that is something we've considered. So one thing that definitely would be featured on the product is a warning label and UV light to say it will not burn you or cause a lot of harm if it is exposed. But we were talking about this before. I don't know if you want to speak more to this. But
an idea that we're still obviously in the manufacturing process, that's where I would come in, but our idea was we could potentially do 2 walls of the flaps. So you have one wall, it's like a double chamber, kind of like a double chamber door. So it goes into like a no light zone and then goes out again, so it protects the users. But you also will be a far distance away from where it comes out, because it comes out and it still rolls for a few feet, and so, yeah, that's what our plan would be.
Thank you.
All right, thank you.
All right, great job, Team Quattro. Next up, we have Phaedra, the first place winner in energy, agriculture, and the environment.
Hello and welcome. My name is Patrick O'Mahony. My name is Max Card, and we are Team Phaedra in the 2021 President's Challenge. We created this project because landscapes like this are getting turned into this because of this.
The lithium-ion battery. We've all seen them before in our phones and our vehicles, electric vehicles. They're touted for rechargeability, having good lifespans, low maintenance, and their sustainability. But how sustainable are these batteries really? So imagine you're in this scenario. You're charging your lithium-ion powered electric vehicle at a commercial charging port. All you, the consumer, sees is electricity coming from the port into your vehicle. However, there's a lot underneath the hood that went into getting the lithium into the batteries in the first place. Dangerous, destructive mining practices, the upheaval of vast amounts of natural resources, horrible conditions for the people surrounding the mines, and dangerous chemicals that can leach into the surrounding environment around the mines.
So these are some numbers about lithium extraction, production, use, and there's a lot here, but I want to draw your attention to 2 specific numbers. The first is at the very top that underscores the scarcity of lithium. Even in mines where there's a high concentration, it takes 500 tons of earth to be moved to produce 1 ton of lithium. Keeping that scarcity in mind, by 2025, we're looking at a tripling in demand of lithium. And so research and development into other more sustainable technologies for batteries in certain industries is really important.
So one of these alternatives is a magnesium air-based battery. Magnesium as a material has many advantages over lithium. For one, it is far more abundant, being the 7th most common element in Earth's crust as opposed to lithium at 33rd. Additionally, lithium is far more challenging to recycle. It is a difficult and expensive process to recycle, whereas recycling magnesium is a fairly simple chemical process. As well, magnesium boasts an energy density far greater than lithium by an order of magnitude. Unfortunately, both these batteries would require miners to get the raw materials. However, our battery focuses so heavily on recyclability, particularly of the magnesium, that we will be forced to go back to the mines far less, reducing the amount of mining that occurs overall dramatically. So here's a quick overview of how a magnesium air battery works. A magnesium anode interacts through a redox reaction with the oxygen in the air around it, creating a flow of electrons which generates the power of the battery. Now, why hasn't this battery seen much commercial success yet? For one, it's a primary cell. That means it's not electrically rechargeable. Additionally, it's not very energy dense. Despite magnesium's energy density as a material, the majority of the magnesium in this battery is located in the anode, meaning it cannot react with the oxygen around it. Research has suggested that to make this practical, it would need to become lighter and have a higher surface area of magnesium to react with surrounding oxygen.
So in order to address this and take this research into account, we created a mechanically rechargeable magnesium air battery, the Phaedra battery. The Phaedra battery uses individual cells that can slot in and out of the battery housing so that when the reaction has run its course, the cell can be taken out and replaced with another one, but mechanically recharging the system. These cells have the magnesium air battery material wrapped around a thin plastic tube, and then copper braces are put on the top and the bottom. These copper braces, when they're fit into the battery housing, connect with the copper brushes that are on the inside, allowing power to transfer from the cells into whatever you're powering or whatever you're charging. This prioritizes consumer usability and also means that mechanically rechargeable magnesium air batteries are commercially feasible for the first time. We also really want to put a big focus on recyclability in this product. Not only can the battery housing and the tubes be made entirely out of recycled materials, when a consumer disposes of a cell, almost all of that can be recycled. So the plastic tube can be reused immediately, and the magnesium oxide, the product of the reaction, can actually be made back into magnesium and reprocessed for more cells through this simple reaction.
Now that brings us to the implementation of our batteries. So far, the batteries have exhibited an 18-hour battery life. This leads us to believe they will be perfectly suited to applications that will be used for extended periods of time or a break to remove cartridges and replace it with the new ones. This lends itself fantastically to the electric vehicle industry, particularly electric vehicle transportations. Buses, trolleys, and electric trucks are going to be on the road for extended periods of time, after which there will be a break for the driver to rest. During that break, these charges can simply be removed and replaced with other ones installed. Additionally, this is going to be a vibrant and growing market. The electric vehicle, particularly electric truck industry, is going to be expanding as the number of trucks and the U.S. transportation fleet is expected to increase dramatically by the year 2030.
So there's a lot more research and development that can be done on this, but we've proved through this that there's a viable prototype and a viable proof of concept for our cartridge design. Thank you for watching. We are Team Phaedra. If you have any questions, ask now. We also have some prototype cells for you to look at if you're interested. And yeah, thank you so much.
You start. You go.
All right. Thanks, guys. Fascinating. Definitely the battery is the future. So I got a couple questions. One is, can you talk a bit about the rechargeability feature? Because it sounded to me like you say that you can replace something in it which approximates recharge, but pretty much you can replace it out. And so is that accurate? Is it replacing out the cell, or is there some way to actually recharge it?
Yeah, so it's mechanical recharging, which means you are physically replacing the cell. Our goal was to make as cheap and light and compact of a cartridge system as we could to make that a competitor with lithium-ion.
Additionally, Additionally, once these have been taken out, the magnesium can be harvested and recycled to produce more magnesium to reapply to the reusable cells. So you essentially take them out, reprocess them, get new ones.
Okay, great. And my second question is quick. So one of the hesitations on buying a Tesla or any kind of electric vehicle is that battery life, not want to stop, charge it, whatnot. Now you mentioned 18 hours. Elon Musk is working on this 1,000-mile battery. What do you all predict this magnesium air battery or Phaedra battery could do in terms of driving and the length of time you could drive?
Yeah, so that's one of the reasons we focused on a industry that is driving long term, because if you're putting it in a Tesla, like a consumer car, then you're going to have to replace it a lot more because the driving is less consistent. But with our future innovations, there's specifically a lot of things you can do to increase that lifespan. 18 hours is kind of where our tests are, but actually those cells that I handed out, I tested those this morning, and they've been running at about 80% of what they were producing in tests for the past 3 or 4 days. And then in addition, there's also alloys of magnesium that are corrosion resistant, and so with more development, we can increase that lifespan for more hours, yeah.
Great, thank you.
You're good? Okay. So my question is, looking at how much energy do you have to put in there to get a complete charge? And the question kind of goes at, sometimes you have to put in 100% of energy, right, and you get 80% charge, right? So what's that energy loss value?
Can you repeat the question again? Sorry.
Yeah, so energy conversion, right? You're putting in electricity to charge it. How much energy do you lose in the charging process?
So the recharging process is to physically replace the
So it's a one-use battery?
Yeah, so what we try to do is the individual cells are single use, right? But then because we created a super light cartridge system, you can physically replace those and recharge those after the day or 2 days that those.
And then how long does it take to replace the battery, to like
just because of the cartridge system, our goal is just to take it out and put it back in. So
right, but once you take the material out and put it here, right, it's done, you used it, how long does it take to recycle it?
The recycling, whatever cartridges or whatever you spend, those are sent back to the company or whatever producer, and then those are reprocessed and resold to consumers as cells.
So, thank you.
At the moment, we don't have obviously an industrial facility, obviously, so we haven't gotten it down, but we do expect it would be a fairly quick turnaround to if we take 50 cells, to quick turnaround to return them, because recycling magnesium is not a very complicated process, and the cells themselves are fairly, I don't want to say simplistic, but they're not going to be very difficult to repurpose.
Thank you.
Okay, quick one. So, what happens if do you have an alternative if the charging, station, for example, fails or something like that? I mean, can you connect this with, say, like solar and all that, to charge?
For sure. This could also be probably combined in conjunction with other systems. Additionally, one thing we could do is, because of how light the cartridges are, you can feel them, they're very light. A bunch of extras could be stored in the electric vehicle, so that if, when driving, whatever array you have in the batteries runs out, you can simply, on a stop, take them out, put some new ones in, and keep on going. So it could be a combination of either that and solar or whatever power, probably solar for an electric vehicle, or simply just having a bunch of extra spare ones that are going to be very light, not going to be a problem at all for a transport truck or a trawler or something along those lines.
Okay, good.
All right, our final team for the pitch-off today, we have Nerf COVID, the first place winner in products and services.
my name's Claire, and this is Colin, and we're going to be talking about our President's Challenge project, Nerf COVID. It's the implementation of UV light to kill COVID virus in bathrooms on campus. First, we'd like you to meet the team. We have Nick Pascua, he's in quarantine right now, myself, Claire Flannery, Lucas Richardson, Colin Graham, and Eric Nowak. So first, we want to discuss the problem, which is the pandemic. This is an image taken from the Johns Hopkins Coronavirus Resource Center website, and this is the cumulative number of cases so far as of yesterday. Huge numbers, as we're all aware of, nearly 3 million deaths. But we decided we wanted to take a closer look and see how the United States was affecting and adding to these numbers. From the same research, we saw, again, huge numbers, nearly 500,000 deaths in the United States alone. And as innovators, as entrepreneurs, we know that you have to take a closer look to solve the problem at a smaller scale, which is how are colleges and universities affecting these numbers, adding to these numbers in the United States. According to a study done by the New York Times, there were more than 535,000 cases, which is huge. And we know that we have to stop the spread on campuses. And this number is still relevant because there was an increase of 30% by the end of 2020. So we decided we wanted to know how we wanted to see how our peers have been affected by this rate and by COVID in general. So we sent out a market research study, and out of our 152 respondents, we saw that 67.8% of them said that they were most concerned with air transmission, which is valid because COVID can stay within air, or airborne COVID can stay for more than 3 hours at a time. We then sent out a second survey for more of a niche market and asked what students considered the most high-risk locations for COVID on campus. And 67.9% of the responses said college bathrooms. And this is where our project began. We knew that we had created a device that could clean the air particles as well as the contaminated surfaces in college bathrooms, and that's how we came up with Nerf COVID and the implementation of UV light to kill all bacteria and viruses. And now I'm going to hand it over to Colin. He's going to talk about why our product matters and how we will present a solution to this global pandemic.
So we had 3 things in mind when we were making our prototype. We wanted it to be feasible, affordable, and efficient. The UV light that our team chose is 99.9% efficient, given 20 minutes for any college bathroom on campus. Since the UV light is harmful to human skin and eyes, we put in measures in place to make sure the user was safe, such as the magnetic sensor, which we will show in a second, that when the door opens, the light will turn off, keeping the user safe. So pretty much, to show the prototype, we have just a normal light bulb in there right now. And the button will be placed outside of the room, so when you leave the room, you press the button, and the light turns on. And then when somebody enters the room, the magnet will go off the magnet sensor, and the light will turn off. So this prototype you see here costs $169, but that included all of our testing, including a $120 Arduino. We think that if we start producing this, we can get it to $62 per unit.
In addition to pricing, we also looked at the competitive landscape, and we have 3 main competitors right now. Those are Amazon, Illumi, and Boeing. Amazon sells their product for about $50 per bulb, but you only use them in showers, really. The UV can be harmful to users who don't know what they're doing. And in addition to that, they don't show the UV indicators, which is a very important part of the process. Illumi is for in-home use, $65 per piece. However, their sanitization process takes way longer than ours. And Boeing is well over $100. They want to implement their product in airports and those public bathrooms, but very expensive. Nerf COVID ranges for about $62, like Colin said, and we'll be using them in college bathrooms. So in conclusion, why would you choose Nerf COVID? It's simple. We're a group of college students, and we're very passionate about getting back to socializing with our friends. We miss hockey games, we miss interacting with professors, we miss crowded student center during lunchtime, everything. And COVID in isolation are detrimental to student health, student mental health. It's even keeping us from seeing our friends that are still at home right now. And the implementation of our UV light kills all germs, COVID virus, flu, cold, and whatever comes next. We will be the driving force that ensures health and safety on this campus and brings us one step closer to normal. Thank you.
Augustine, you want to go first?
So I think this is good. Have you considered other markets other than just college bathrooms?
So other companies are targeting other markets like airport terminals and things like that. So we wanted to start out on college campuses alone, specifically bathrooms. But as we grow, we hope to put our product in different spaces. But starting off, college bathrooms we think would be the perfect market for us.
Okay, I have a quick question. So, just for clarity, are we talking about the entire bathroom or stall in the bathroom?
Yeah, so it would be the entire bathroom. It would cover the
Okay.
space of the entire area.
Okay, so then I have a scenario. Let's say, for instance, I go in this bathroom like you demonstrated. I go in, it cuts off, I go back out, it cuts back on because I flip the switch. But let's just say I take my little brother in there with me. I go in, and then I go out and I say, hey, I'll meet you outside. When I close the door, is the light going to come on and just burn the skin up?
No, we're going to make it, there's going to be a sensor to it. So that it doesn't detect any human kind of interaction within the area, just because it is harmful to skin. So.
Yeah, just to add on to that, this is obviously our first prototype, so we're still adjusting it, but we also want to add a PIR motion sensor, so that when we add that, if there's still motion in there, obviously it won't turn on. So that's something that we still have to add, but this is kind of just our first prototype so far. So.
Thank you.
Yeah, knowing that light doesn't bend around corners, right? How many of these devices do you think you have to have in the bathroom to effectively sterilize it?
Yeah, so this is something that would obviously depend on the size and dimensions of the bathroom. Obviously with stalls it makes it a lot different because it's not going to be able to go around the walls. So it would be dependent on how many stalls or whatever is in the room. But that one machine can power as many UV lights as we want, so we would just have to install UV light attachments for it to go into over each stall or around the room. I currently live in Moore right now, and we can clean the entire room with 2 of them right now, so that's obviously a smaller bathroom. I don't know if you know what it is, but it depends on the size of the bathroom.
Yeah.
So to add on to that, our bathroom that we did the testing for a prototype in Moore has a sort of C shape to it, and it's 48 square feet. And with 2 lights, we'd be able to reach around all the corners and effectively disinfect the entire room.
So did you do testing of the bathroom after you turned the light on?
Could you repeat that, sorry?
Did you do testing of the bathroom for any viruses or bacteria or anything after you turned the light on?
Yeah, we, for our testing, we used a Quantidos card which measures the amount of UV light on a surface. So we put it on various walls to measure how much radiation was going to each wall and if it was actually effectively cleaning that surface. So we put the UV lights at random places and these surrounding, and it was 99.9% efficient.
No, that's good. In a final product, you should add those in as...
Yeah, this is included in the final product. We should have mentioned that.
Good, thank you.
Thank you.
Okay, great job to all the teams. That was amazing and wonderful to watch. Oh, sorry, Blake. All these protocols. You're doing wonderfully. Okay, so all of the teams in the President's Challenge also submitted videos that highlight their projects. Our team of students have compiled all those videos and we'll be showing them in the break while our judges go and deliberate in the CUSA room. So as soon as we have those results in and the videos are done, we will be announcing all of the winners. So without further ado, we shall show the videos. Thanks all.
Balancing demand for energy with the need to fight climate change is a major challenge. The burning of fossil fuels to produce energy is a leading cause of harmful greenhouse gas emissions. The United States alone contributes to more than 1/8 of the total global emissions. Of that, 22% are from industry. The trucking industry is a major contributor of these gas emissions that are pushing our planet towards the point of no return concerning climate change. Unnecessary emissions are produced every day as these trucks are often required to idle for long periods of time. Base solar provides a solution using solar panels to produce renewable energy that replaces the need for idling. Seen here is a digital rendition of a possible scenario of the use of our product. The charging station, solar panels, and connections are all shown in professional drawing. Base solar is designed to be installed on warehouses, distribution centers, and rest stops. We replace the need to idle when loading and unloading, running auxiliary equipment such as lift gates, and/or maintaining trailer refrigeration. Base solar is user-friendly, environmentally conscious, and has user interest. We are a solid base to eliminate idling waste.
Hello, welcome to the Concrete Canoe Workshop. My name is Robert Schneider, and I am this year's captain. In a typical year, we partake in the ASCE, American Society of Civil Engineers, regional competition in hopes of going to the national competition. To construct a concrete canoe, we must first start with the CAD model. A series of cross-sectional pieces are cut to approximate dimension and then sanded down excessively, requiring a long period of time. As you can see in this model, the pieces are then adhered together and concrete is placed on top of the surface. Current market, there's an absence for foam cutting machinery. Our team has tackled this issue by creating a hot wire CNC machine. The team lacks various components. To remediate this issue, we reused several key components from the starting electrical device, including jumpers, switches, wires, extruded aluminum T-slots, belts, and pulleys. Keep the machine running. This here controls the temperature of the wire and needs to tell the machine its home location. Here are the results. This first prototype shows promising capabilities and can be applied to all sorts of casting, mold making, and modeling needs. We hope to implement this into the makerspace. In future iterations, we hope to target a wider industrial audience.
Well, while we are under a mask mandate these days to cover up in public and help stop the spread of the coronavirus, some folks who wear glasses are having a problem. You see it right there. They can't see because their lenses steam up.
Are you tired of your glasses constantly fogging up? Because of the COVID-19 pandemic, people who wear glasses know the struggle of their glasses fogging up while wearing a mask. It can get in the way of everyday tasks like working and driving. Nearly all face masks force the hot air you breathe to go up your face right onto your lenses, causing them to fog. And many store-bought sprays and household solutions are not effective at keeping the glass from fogging up and have to be constantly reapplied. Well, we have the solution for you. Our solution is a glass frame with built-in wires powered by batteries that heat up the lenses. Current from the battery heats the wires that touch the lenses you see through. The heat applied to the lenses increases its temperature, limiting the temperature difference in which fog can be created. Glass fogs up when hot air hits a cold surface, causing the water molecules to leave an excited state and stay on the cold surface.
ClearSight was designed to be a long-lasting and more permanent solution to your glasses fogging up. The nichrome wire technology we use allows heat to flow easily through your lenses. Our product is a one-time cost for users. They don't have to come back and repurchase it over and over. The batteries allow for a long-term fix, whereas current solutions like sprays and pastes need to be reapplied almost hourly.
Our product is the Splinter Buddy. Foreign objects can be lodged or stuck in the skin that leads to discomfort and potential long-term injuries or infections. When young children have slivers in their skin, it's not only a challenge to remove the deeply embedded debris, but to get them to stay calm and to keep still, even through the tears.
Our team has created a solution to this problem in a unique way that offers an alternative to removing splinters. The Splinter Buddy operates from the force of suction that is generated by the syringe. In order to ensure a tight fit to the skin, the Splinter Buddy has removable tips of different sizes and shapes to provide the best angle and fit. There are current ways to remove objects from the skin, such as tweezers, but this results in a great amount of pain while trying to dig the object out. The Splinter Buddy is a device that can remove the splinter, allowing for quick and easy relief. The Splinter Buddy will be superior to tweezers because it will be less painful, faster, and easier to remove foreign objects from the skin. The Splinter Buddy comes in two sizes of 12 milliliters and 25 milliliters for different amounts of suction force. The 12 milliliter model costs $4.99, while the 25 milliliter model costs $7.99.
Tweezers are the current competition for the Splinter Buddy, but do not compare. Tweezers are difficult to use, dig into the skin, and can cause a great amount of pain. The Splinter Buddy is the best way to remove any foreign object from the skin, with no pain, quick efficiency, and great prices.
Many Americans want to get in shape, but they don't know how, or they try some fad trends such as cutting all carbs and doing an excessive amount of cardio. This lifestyle is unsustainable, and eventually they will give up. Fitspire is a motivational fitness app focused on helping all Americans at all different fitness levels by increasing their knowledge in nutrition and exercise, and personalizing the app to keep them motivated and engaged. 5 icons will appear at the bottom of the app. The nutrition icon. The nutrition icon stores information ranging from how many calories they should eat a day depending on their goals to what certain foods can do to their body. The workout icon. This icon has 2 programs, one for at home and one for at the gym. The same muscle groups will be worked, the difference is the availability of equipment. The goals icon. This icon will start with a 14-minute body scan to increase implicit motivation and increase mindfulness. Once completed, 5 goals can be inputted with a deadline. Once completed, the goals will be moved to a section called Previous Goals. The motivation icon. A self-imagery exercise will appear when setting up the app. After that, a daily inspirational quote to improve mood will show up every day. The profile icon. The profile icon will be personalized to each user by analyzing the information they input. It will tell them how their actions are specifically affecting results. The beauty of Fitspire is that it is not like other apps. It treats every person differently by effectively analyzing how the user's behavior is affecting their results. Fitspire will change how Americans view health and fitness and will change lifestyles.
Dude, I'm so thirsty, but there's like nothing to drink out here.
You can have the rest of my water.
Thanks.
Hey, come check this out. We can make one of these and we'll have water in no time.
Really? Yeah, I got most of the stuff lying around.
In today's world, individuals who are elderly or disabled often have mobility afflictions, and they might use a cane, walker, or other device to keep their balance. However, these people can sometimes drop, lose, or leave their device behind, which can lead to accidents, falls, and medical emergencies. Currently, there are no solutions to this problem that do not burden the user or make them feel comfortable during use. Today, we are introducing the Keep Your Cane, an innovative and ingenious product that will keep these individuals and their canes together at all times, all while supporting usability and comfortability. The Keep Your Cane consists of three main components: a special bracelet for the user, a clamp that attaches to their cane, and a retractable cord that connects these two pieces. Each of these three components works in tandem to keep a cane user and their cane together at all times, significantly reducing the risk of falls and increasing the safety of its users. We plan for the Keep Your Cane to be worn at almost all times during the day. When a user wakes up in the morning, they put the bracelet on, and when they go to bed, they take it off. If you or a loved one needs to use a cane in your daily life and are scared of falling and becoming seriously injured, the Keep Your Cane is here to put you at ease.
Every year, 72 billion tons of food are thrown out in the United States. If that wasted food was distributed to each of the 42 million food insecure citizens in the country, each would receive more than 1,700 pounds of food for themselves. Food waste accumulates from restaurants throwing away food that was prepped and cooked in the kitchen but never reached the table. Through overstocking food, restaurants find themselves filling garbage cans every night, adding costs to their bottom line. The Earth's climate also suffers at the hands of food waste. It piles up in landfills and emits greenhouse gases, contributing to global warming.
Food Waste Eraser is the solution to these issues. Food Waste Eraser is an online program designed to optimize and enhance kitchen efficiency through tracking restaurants' unique data and the factors that surround it. This can provide an accurate forecast to the restaurant owner on how much food will be consumed, ordered, and wasted in the near future. Weather patterns, the time of year, staffing, the day of the week, the menus offered, and the presence of local events all influence food waste generation. Our application tracks these factors for owners, establishing trends. With this knowledge, restaurant owners can make better informed decisions, relieving their costs and benefiting the environment by preparing an appropriate amount of food. Food Waste Eraser is here to help. Are you ready to work together?
The COVID-19 virus has changed the world. Safety has become more important than ever with sanitizing products being sold out of stores. Disinfecting wipes are being used at an exponential rate by facilities across the nation to keep up with these strict guidelines. 3.5 million tons of plastic and other solid waste is created every day and can take years to decompose. COVID-19 is a more recent issue causing almost 131 million cases and 3 million deaths. Our solution aims to combat these issues introducing Megvie's Sanitation Glove. So, what is the sanitation glove? Our product is a rubber glove with an absorbent cloth on the palm and fingers that facilitates cleaning and sanitizing. This product is an ideal for those who require constant sanitation such as gyms, schools, small businesses, and homeowners. The reusable sanitation glove provides solutions to many problems. The glove has ethically and sustainably sourced materials, is an easy way to clean, provides protection of users' hands and arms from hazards and cleaning solution, and it's recyclable. The Megvie glove is the first of its kind. Since the glove is reusable, consumers save money by buying one pair of gloves rather than many disposable wipes. The glove has better mobility and control since it's on the user's hand. The number one goal of Megvie's is safety. We want you to feel safer during the ongoing pandemic by providing you with proper sanitation that is environmentally friendly. Help us save lives and the environment and purchase a pair of sanitation gloves.
And I'm Eric. We're doing the President's Challenge to stop the spread of COVID on campus.
We're going to talk about the dangers of COVID, how our device works, and how we're going to implement it on campus.
Roll the tape.
Limited research has shown that shared bathrooms on campus have the highest rate of COVID at Clarkson. In fact, COVID can stay in the air for up to 25 days. However, UV light kills COVID. That's why the team decided to make a UV device that kills COVID and other diseases in bathrooms.
Hey guys, my name is Colin Graham and I'm on the President's Challenge team. Here you can see our prototype. You put your light bulb in, you plug it into the outlet. And when you exit the room, you click the button and the light turns on.
Colin, what if someone tries to enter the bathroom?
Well, it's a good thing you asked that. We have a magnetic sensor here and a magnet on the door, so when somebody opens the door, the light turns off.
Huh. Why aren't you using the UV lamp we bought?
Well, usually we would, but since UV light is harmful to human skin and eyes, we decided not to.
Oh, I get it now.
In all seriousness, COVID has been a wake-up call for all of us. It has been exposing hotbeds for viruses on campus.
It's time to get ahead of COVID and other transmittable diseases for the future.
Our product is a potential solution to this global problem.
Hi, I'm Cameron Palmer, CEO and founder of Palmer Technologies. Based on Clarkson University's beautiful Potsdam campus, we're working to solve a very important problem. The problem of plastic waste. I'm here in Clarkson's Dorf Makerspace, where they have 7 3D printers. These 3D printers are running nearly 24/7, producing useful objects and prototypes for the Makerspace's many users. With the aid of 3D printing, you could turn this plastic waste into nearly anything you can imagine. That's where we come in. Palmer Tech works to turn ugly discarded plastic into 3D printer filament that can be used to create, well, anything. This is our shredder. It has 14 stainless steel blades that are used to grind up plastic. The best part is that this machine doesn't care if plastic is a water bottle or a 3D printed object. Either way, this is the result. From there, our custom filament extruder takes care of the rest of the process. So there you have it. At Palmer Technologies, we believe that using the filament we're developing, everyone will be able to help print, recycle, and repeat, making our world a better place to live in. Thanks for watching, and don't forget to smash that like button.
Welcome back, and as the team gets reset up for our award ceremony, I just would like to thank a few individuals for helping out today. First, Matt Hawthorne, class of 19 and 21, our Ignite graduate fellow who we're going to miss. He worked tirelessly on this year's President's Challenge, working with the teams, working with getting today's event set up. And so thank you, Matt, for all the work that you did to get the teams here today. Also, Ben Moeller. Ben's up in the back there running the IT, and he helped us with the YouTube videos and splicing all those together. He's also an Ignite grad fellow graduating this year. We're going to miss the two of them. Also like to thank all the guys on the OIT team up there. They're rock stars. Today's setup was pretty complex with Zoom and YouTube Live and mics here and mics there. So thank you for all the thought and effort that went in to making this a reality for us for our hybrid event today. Also thank Ann Barrett, our program coordinator, and Davis Rogers in the back, our administrative assistant, for helping throughout the year, and all the students and faculty who have helped be advisors for our teams as well. So I hope you enjoyed seeing the videos. We didn't get through all of them. They are all on YouTube, so if you have a chance after today to watch the rest of those, we'd love for you to see them, and they'll remain up there on our YouTube channel. Are we good? Okay. So this year's challenge really not only pushed students to create unique and innovative products, but to do so through long winter break, through a campus precautionary quarantine, and the resilience that they showed really can't be understated. I'd like to again thank the faculty and staff who helped push them through that and stepped in to mentor the teams. I know a lot of the Maker Mentor staff in the Dorf Makerspace and our digital making suite. I should thank Blake too, who's also been helping. There he is, helping today with the event. Really helped and stepped in to help mentor the teams. So let's start the awards. All right. President Collins and I will announce the awards. In addition to prize money, teams are going to be receiving a certificate and an Ignite ribbon. So if teams are here today to accept awards, we'd love for you to come down. We'll take a quick picture. And if the teams are not here, we will mail any of your awards out to you. Let's see. So our first award was for our use of campus resources, and this challenge really asks students to take advantage of the resources that exist on campus, and for doing that, they received points. So I'd like to thank the staff of the Writing Center, the Dorf Makerspace, the Digital Making Suite, and the Shipley Center for providing those workshops and getting the teams ready today. This year, one of our teams actually attended all of the workshops that were available in both the Dorf Makerspace and the Digital Making Suite in order to bring their project to life. And for this reason, we did a four-way tie. This is generally an individual student award. We did a four-way tie for that team. So instead of two $500 awards, there will be four $250 awards in this category. Tony.
Thank you. So the most fun part of the day. The team who has collectively won the Best Use of Campus Resources Award is Team Quattro.
The next group of awards represent some of the core goals of Clarkson, and in particular with the President's Challenge. There will be 6 of these awards. They're $500 a piece, and they each represent one of the goals of Clarkson Ignite.
The award for Best Collaboration Among Disciplines goes to Palmer Technologies. The award for Greatest Commercial Potential goes to Phaedra. 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 I'm not sure you want. The award for Most Implementation Ready goes to MEGB. The award for Most Innovative Idea goes to E. Maniacs. The award for Best Class-Based Project goes to, again, Team Quattro. The award for Best Extracurricular Project goes to Concrete Canoe.
Our next award for Best Prototypes is new this year. All the teams were judged based on how well their prototype solved the problem as presented. First, second, and third place awards were determined based on the showcase that was held Monday in the Dorf Makerspace.
The third place, the $250 winner for the Prototype Award goes to Nerf COVID. Second place, the $500 winner for the Prototype Award goes to Los Perros. So, no surprise here, the first place, the $1,000 winner for the Prototype Award goes to the environmentalists. Just cheating, trying to find.
Next, we have our video award. These winners were selected by the audience vote through YouTube from Monday at 10 a.m. through yesterday at noon. Amazingly, guys, there were altogether over 14,600 views of the team's videos, and that represented over 133 watch hours and over 2,200 total votes. So great job sharing your videos out there.
So, the third place $250 award for the Video Award goes to Concrete Canoe, third place. Second place, $500 for the video award goes to MEGB, Megby. And first place for the $1,000 for the Video Showcase Award goes to the Smart Throne with over 500 votes.
Okay, now we'll move on to the category-specific awards. We will be awarding second and third place awards in each category, in addition to the Best in Category award. Third place teams are receiving $750. Second place wins $1,500, and as previously announced, the Best in Category team wins $2,500 each. We will announce these awards by category, and the first category we'll be announcing is the Human Health category.
The third place in the Human Health category is Fitspire. Second place in the Human Health category is the Keep Your Cane. And definitely no surprise here, the best in category for human health is Team Quattro.
We'll now move on to Energy, Agriculture, and the Environment category.
Third place in the Energy, Agriculture, and Environment category is Team Base. Second place in this category goes to Megby, M-E-G-B. Oh, sorry, I missed it. The best in category, again, no surprise, for Energy, Agriculture, and Environment is Phaedra.
And now our final category before we announce the overall winner of the 2021 President's Challenge is the products and services category.
Third place in the products and services category is Concrete Canoe. Second place in the products and services category is EM Maniacs. And best in category team for products and services is Nerf COVID.
Okay, on to our final award today, the President's Challenge Grand Prize winner. This award is based on the pitches that we heard earlier this afternoon, and the team that wins this will receive an additional $1,000 award and have their name added to our President's Challenge shield. President Collins, please do the honors.
So, a little drum roll. Are you nervous? Yep. Thank you very much. And the President's Challenge winner is Nerf COVID.
Well, congratulations to all of our teams. Our winners today are going to hear very soon from Ann Barrett, our program coordinator, and she'll work out the details for you to receive your prize money. I'd also want to just recognize our maker mentors who made us an amazing stand for our President's Challenge shield. So they did a great job figuring that out. Thank you, guys. And thank you all for participating, for coming today. It's just energizing to see the work that you've been able to do and to see you guys in person. And thanks all for joining us online. There's been nearly 60 or more folks joining us online throughout the afternoon event too. So thanks to you guys for sticking with us. And we'll be back again for the 2022 President's Challenge next year. And so keep an eye out for that. Thanks for coming, and stay safe and Clarkson strong. Have a great night.
Thanks, Eddie. Not too shabby, huh? No. Went smoothly.
Did I forget to thank anybody?
What? No, I don't think so.
Good.
No, it was like 8 good points. You're good enough.